All right, number 7, we want to assume the limit of f of x as x approaches 1 is equal to 8. And then we want to compute the limit and state the law to justify the computation. So this looks like the power rule. So we have the limit of f of x as x approaches 1. And we are raising this to the 2/3 power. According to the rule, we can just evaluate this limit and then take this root or raise it to this power. And so since we have already evaluated that the limit of f of x as x goes to 1 is equal to 8, basically we are doing 8 to the 2/3 power. So you can either do the cube root of 8 and then square it, or you can square it and then do the cube root. I like to make it smaller first. So the cube root of 8 is 2, and so this ends up being 2 raised to the 2nd power, and then we end up with 4. And this is due to the power rule. I don't like the power rule, the root, sorry, because we are using the root. Select all that applies. So we have a power and we have a root. I just overlooked the select all that apply. Number 8, it wants to know how are the limit of p of x as x approaches a from the left and the limit of p of x as x approaches a from the right calculated if p is a polynomial function. So if this is the case, we would approach and plug in numerical values from the left and right and see if they are equal. So limit p of x is equal to the limit of p of x from the right, which is equal to a. Left is equal to the right if it's equal to p of a. B looks good. Either limits may not exist. Limit p of x as we approach a from the left and approach a from the right is equal to 0. So if we don't know it's 0, it's going to equal to whatever that function value is when we plug it in with direct substitution.